Hello everyone, welcome to the next session of ANSYS Workbench tutorials. In this session, we are solving an analysis for a SAE Hub which is subjected to some sort of loading. We are going to test it for its fatigue analysis. We will start with double clicking on static structural. I'll first go to geometry, right click, import geometry. I already have the SAE Hub ready with me, so I'll directly import it into my geometry. Next, I'll go to engineering data. I'll be using structural steel. I'll go to this interpolation part. Instead of log, I'll change it to semi-log. And you can see here the value of stress is 86.2, which is the maximum stress or the yielding stress for structural steel. If the value of stress generated because of the loading exceeds this value, then the part will have a shorter lifespan, or it will be failing with minimum number of cycles of loading on it. But if it is less than this value, then it will be safer. More than this value is unsafe. So we'll go to project and update the project. Now I'll go to model and double click on it. You can check here in geometry, the part 1, part 2 and part 3, all three of them have structural steel as the material. I'll go to mesh, I'll choose the sizing as fine and update. Next, I'll go to analysis settings. Now, in this SAE Hub, this portion is the one which is supposed to be fixed. So, I'll select here, insert, fix support on this, apply. Next, I'll apply moment on this bearing portion. So, this will be insert, moment. I will apply moment along the z-axis as you can see here. So let me apply the moment as 80,000 Newton mm. This is in clockwise direction. Next, I'll apply load in these portions. So that is going to be bearing load. So I'll choose one bearing here. Next, I'll go to size over here. And I'll select all entities with the same size. So you can see all these same size holes are going to get selected. Next, I'll go to vector and I'll change it to component. Let me apply a load in these bearings in the downward direction. So downward direction is Y. I will apply, say, a load of minus 500 Newton. I'll go to solution and insert stress tool. Maximum shear. I want to see the deformation total. I also want to see the equivalent stress on the body, that is the von Mises stress. I am going to insert fatigue as an option. This is the fatigue tool. I am going to choose mean stress theory as the Goodman theory. I leave the load as fully reversed type. In fatigue tool, I want to check the life of this SAE Hub. And I also want to check the safety factor owing to these conditions that we have applied. Next, I'll go to solution and solve. Now we will see the results. The first result we are going to see is the total deformation. This is the total deformation on this hub. You can see here the maximum value is 0.003936. This is in the red zone that you can see here. You can click on max min so you can see the maximum and the minimum values. Next, I'll go for static loading factor of safety. You can see here this entire body is extremely safe in static condition and the value of factor of safety is greater than 10. So it's absolutely safe. Next, I'll go for equivalent stress on this body. you can see the equivalent stress is 13.664, and we saw that the maximum stress or the yield stress is 86 megapascal. So this is nowhere close to yielding. This body is completely safe right now. Now we will see what happens if there is a fluctuating type of load. For example, fully reversed load. So we will go for fatigue tool. In that we will check the life of this body. You can see that this body can work up to 1 into 10 raised to 6 cycles. Now if you want to see the deformation, you can animate and check. This is how it is going to work. It is going to have moment factor higher than the bearing load, which is in the downward direction. So it will have a kind of rotating motion, and the life is 1 into 10 raised to 6 cycles, for which this is going to work. The factor of safety for fluctuating load is 6.3, which is quite greater than 1. So your body is absolutely safe under this type of loading. Now, depending on your application, you can change the moment and the bearing load and analyze this hub for its value. Equivalent stress value that we have obtained is exactly at this junction between this bearing and this hub. So this is the zone where you should actually have your maximum stress value, and that is what you can see here. So as per the requirements of the result, we have got the deformation, which is of rotatory type, and the equivalent stress at the junction. We have also seen that the life and the factor of safety value is much greater, and this will work for a particular number of cycles before it completely fails. So this is how you do the fatigue analysis for an SAE hub. I hope you have understood the procedure. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. See you in the next session. Thank you.